All right, ladies and gentlemen, moving on to the next one, we have a keynote presentation on optimized hardware and SDV. Optimized hardware for SDV, who is going to be given by Mr. Srinivasan Parthasarathy, who has 24 years of experience in the semiconductor industry and now works as Senior Manager Sales Account Management at Infineon India Automotive segment. Can we all give him a huge round of applause, everyone? Mr. Srinivasan Parthasarathy.
Good morning, everyone. My name is Srinivasan Parthasarathy. I work for Infineon Semiconductor Technologies. I am based out of Bangalore, and all the softwares what we talk today, like why software-defined vehicle is changing the overall landscape when it comes to automotive. The most important part for the software to work is hardware. Okay, so there we play a very major role. So hardware without a software is nothing but a sand. As you know, the raw material for the semiconductor is coming from the sand. So if it will be a pure sand if there is no software to it. So no more can do a very logical functions. It has to add value to it only with the software. Okay. So like everyone spoke, right? So what is making this software-defined vehicle? First of all, we should first say that when there is a traditional ICE engine is moving to the electrical vehicle or a EE architecture, so the hardware plays a very major role. It is not only for the electric vehicle, even for the ICE engine, software plays a very major role, and also the hardware is most important for the software to make its full functionality. Okay, so the most important thing, like previously we had a personal digital assistants, then a feature phone. Both together, it became a smartphone, right, in the year 2007 or so. So what it really does, so it is nothing but, it is giving me a more personalized, I would say a media for me to communicate to the world. And at the same time, it has a unified hardware. So how I can be more health conscious, or what are the things I do my activity. So it has shared with the software ecosystem, which is built around it. Similar way, what is happening is, when it comes to the automotive industry, like how the mobile phone has taken a revolution. So you see the mobile phone with a wheel, so which is nothing but, it is nothing but a software-defined vehicle. Like I said, it has the complete hardware built to it. And what are the changes that is happening, or it's also taking a transformation over a period of time. With respect to the hardware point of view, I'll be in a position to cover today with a couple of slides. Okay. So the first one, if you see, there are two particular domains, or I would say when you divide the vehicle into the two parameters, right? One is the power distribution, and another one is the data signal and distribution and computing. So the software comes majorly into the lower part of it, which is the data signal distribution and computing. So Infineon is one of the key player. We are number one in microcontroller, and we are number one in power semiconductors. We have all the complete power ranges, starting from the FinFET technology and from the GaN, and also from the latest silicon carbide. So Infineon has a wide range of product and also the wide voltage range. When I say wide voltage range, it can also operate for a 48 volt architecture. It can go even up to 1200 volt architecture, which plays a very key important in terms of range, performance, the power. So these are most critical things. So if you see the first one, today we are in the Gen 1, where we are talking about the centralized, or I would say the power distribution system. When it comes to the electrical architecture, it is more a domain architecture. Like you have infotainment, then you also have power steering domain. The next one, what we are going to know is that partially, like even in an ICE vehicle, what is today available, there is a partial decentralization is happening. It is not fully moving to the zone, but it is partial decentralization happening. So today, if you want to implement ADAS, right, let it be a level 2 or whatever it is, most important factor is you should have a electronic power steering. What comes important? A safety redundant, a microcontroller, which is most important, critical ECUs, electronic control unit, to implement a ADAS application. Next comes the decentralization is going to happening, where people are more talking about a car will become a full computer, where the driver will become a passenger, these are very standard terms today people talk. So the driver become a passenger, and it is becoming more moving to the zonal architecture. So there will be multiple zones which will be controlled by the high performance computing. Okay. So what are the key things when it comes to electric architecture? So one is very clear, hardware is very important along with the software, and what is going to be the differentiator is the electric electronic architecture for to enable this particular software defined vehicle. So what are the three key parameters? Automated vehicle, then you have the user experience. In automotive, there was always one particular thing always people used to say, you pay for what you see. Okay, now the trend is moving towards you pay for what you feel also. That is the reason you see climate controls are more than you have ventilated seats. So apart from what you see and pay, you also see what you're going to feel also is going to pay for it. Then comes I would say the motion control. Okay, today people more talk about performance, like how the turbo got introduced in an ICE engine. Today, even in electric vehicle, people are talking about how I can have a boost inverter. So a boost inverter can be a 10 kilowatt, but how much fast it can give the performance. Say everyone talks about 0 to 100. If you see the typical ICE engine, 0 to 100 is always between 4 to 6 seconds, even for a high-end premium the sports cars. In electric vehicle, these can be further optimized, and we can get more, I would say, the power, it is in a very short span. That is the reason if you see all the electric vehicles 0 to 100 are much less when you compare equal with the ICE engine, because there is no loss. The motor is directly coupled to the wheel and is able to accelerate fast. Okay, so one is mechanical structure, then most important thing is thermal. Okay, in electric architecture, if you see today, I think last month, if I remember correctly, there was a bus which got burned because of the short circuit in Bangalore itself, right? The JBM company and near the Hebal. So the safety, which is very critical. Even in the panel, there was one person who was also mentioning, you know you're going to update the software, but who's going to go and change to the service station to tune the sensor? This is exactly happened early this month in the BMW case also. More than 1.5 million vehicle, they made a recall. They found, yes, there is a brake issue. It will not fail. You need to apply more, so it still maintain the function. But it also gives a warning to the driver, you need to go to the nearest station and you need to change at the zero cost. So what is important is how you are getting alert and what are the tunings that you are going to do. Even if you do a software update, what are the changes that still you need to go with the service station. These are most important. For that, Infineon plays a very key role when it comes to sensor, when it comes to compute, also when it comes to, I would say, the connectivity. Okay, so what are the basic connectivities we also provide? Okay, so what are the value drivers? I think Praveen also spoke in the morning, what are the key value drivers? It's more personalized, right? So the moment I enter the car should see with the facial recognition, it also should change of my seat settings, my driving pattern. If someone takes from my family that takes the cars, they wanted to have the same feeling. So the driver, when you say the driver or a passenger, the moment they enter, the car need to get personalized. This is only possible only if you have more and more sensors and more, I would say, softwares attached to it. And the innovations and I would say the differentiations especially is only happening through this particular architectures of electrical running architectures. See, the traditional, I would say, the automotive OEMs. Today, I think even Praveen was mentioning the same today in the morning. Today, our customers are not only tier ones. Our customers are also the OEMs when it comes to semiconductor. They want to know what is our roadmap and what is their roadmap, how they can scale it up also with the same platform. They don't want to do the complete architectural change. They want to do only the software update so that they also keep changing the hardware also to it, which is very important. Okay, so when it comes to the vehicle networking, which plays a very crucial role today, like I said, today we are in the domain architecture, which means there are multiple ECUs managed by multiple microcontrollers and to go to the expand and to the end node. The next one, what is coming over is the mixed. We are already in the mixed. The low-end cars, I would say we're presently with the domain, but you are already moving to the mixed and also the zonal architecture, where there are certain level of softwares and a certain level of, I would say, updates and other things are happening over there. But the next one, what we are going to see is the complete full computer, okay, which means there are multiple zones or multiple ECUs, which is centrally controlled by the high performance computing. It can be either connected to the cloud or to the processor or whatever it is, but how the updates are going to happen, that is most important. Most important thing, hacking, right? So once when the vehicle is connected, hacking is very much possible, right? So safety plays a very clean role, and also cyber security. So if you see today, previously the microcontrollers will be for say 8-bit microcontroller, 16-bit microcontroller, but it just had an external memory to interface or to store the data. Today, safety and the security is most important. Why I keep saying safety again is that redundancy. If something happens, do we have a backup even for the hardware to take over and up to certain level and give a certain level of security to it, safety and security to it, okay. So here if you see, these are the three key functions or the challenges also what today most of the OEMs are trying to face. Today if you see, the tier ones makes the, I would say the ECUs, the application software what Praveen mentioned today, it's exactly the same. Application software, even the look and feel of the infotainment systems, the OEM wants to completely own it. The reason being, in case of domain control, they give only the basic parameters and the IPs are still maintained. If you open up the electronic architecture, the whole, I would say the IP and other things, not to the IP level, but you can fully understand how this particular vehicle is different from someone else. So these are going to be very key role, and OEM plays a very major role when it comes to electronics architectures. Okay, so like I said, the cyber. So what we are from Infineon, Infineon we don't play on the processors, we play only on the microcontroller, sensor and other power devices like I said. So we take care at the node level itself. When I say node level, at the ECU level itself. I will also share you what are the products, especially to software related products that Infineon offers, and what are the ecosystems also we are building around to it. Okay, so if you see, this is the overall scenarios where the vehicle motion domains are working towards it. And like I said, there is a generation 1, gen 2 and gen 3. So as far as the products or also the semiconductors is concerned, it's more or less the same, depending on the software and also the criticality of that ECUs. There are multiple level of software microcontrollers and also the sensors that we also work with the customers and also with the tier ones. Okay. So this is the most important point, and like I said in the beginning of my starting of the presentation, how hardware plays a major role. If you see today, we from Infineon, we have a microcontroller. All these are microcontrollers, by the way, but the difference is, when I say the first one, the RX microcontroller, which is a SLD microcontroller. So anything when it comes to safety, security, all these are well covered. Next comes the Travio microcontroller. So the whole semiconductor industry is going for merger and acquisition. So this particular Travio microcontroller came through Infineon through Cypress acquisition. So Cypress itself is more than three companies inside that organization. So the Travio microcontroller is mainly for the SLB. So even in an electronic architecture, not necessarily you need everywhere an SLD. So some places, even if the infotainment doesn't work, it doesn't mean that you can't move the car, right? So there even SLB is more than enough. Then comes, like I said, the touch sensors and also the BMS analog front-end devices. We do also have the PSOC, which is known as programmable system on chip. Now, when the market is also more moving towards, these are proprietary cores. The RX is a proprietary core. Travio and PSOC is an ARM core. Next comes, we are also working on the RISC-V, which is an open source architecture, where we are having, like I said, all these peripherals want to get integrated to it. So which can tandemly work with the sensors, nodes, and also with the processors to make the fully a software defined vehicle, accessible and also with the complete safety and redundancy to it. Okay, so when it comes to software, right? So today the OEM, when I said they have started developing their own application softwares, right? So what the OEM also want to know, how I can reduce my software time development. Also, who will take the ownership? That's the most important thing, right? So today, if you see, like the BMW experience, BMW found the fault. The tier one also accepted, yes, it was our particular braking system which is getting failed. So who's going to take the ownership for it? Similar way, the hardware, we from the hardware semiconductor companies, we are also now more and more focused towards how we can sell the softwares so that the OEM or the tier one time for development is getting reduced along with the ownership. When I say the ownership, the production ready softwares. Okay, so these are the softwares when it comes to safety, security, and also like a modular approach, right? So we give the hardware, we also give the MCAL layer along with the associated softwares. So the OEM or the tier one is more focused on their expertise, their software developments. Okay, so the key takeaways today. So it is very clear, hardware is most important for the software to work. The second point what we are wanted to say is that there's a huge opportunity for each and every value chain. So today if you see the traditional two-wheeler makers in India who are dominating the industry for so long, today you see there are so many, I would say that light electric vehicles are able to come into the market. There are multiple issues over a period of time, they'll also try to fix it, but they're able to bring in the differentiator. So it is, I have a skill set, I will try to build it on my own. That is the most important thing to everyone to play on this particular value chain. Okay. The last one which I wanted to say, like I said, we at Infineon, no more it is a hardware sales. We also go on a solution level. When I say solution or a system level, I go with a microcontroller. I also need to see what are the other associated or the sensors, the peripheral power and everything. Though we have not covered much on these slides with the limited time for the power, Infineon is one of the very key player, thanks to the traditional Siemens, this one also. And with all the German OEMs, Germans, and also with the Chinese players, we have a very good engagement and we are really winning many sockets when it comes to microcontrollers, when it comes to power and other sensors applications also along with the connectivity. On the connectivity though I not mentioned, we play only on the Bluetooth and Wi-Fi. We are not into GSM, we are not into 6-LoWPAN, LoRa, all the other things we are not. We are only into the standard features of say Bluetooth and Wi-Fi. Those are the key things. So we sell the hardware, we also sell the complete participate in the system, how we can contribute to the overall, the OEM or the tier one development. And we also make the production ready softwares for some of the things. And we also have a couple of partners whom we also work very closely like Vector and other companies, Electrobit and more other people also associated with us when it comes to the complete software ecosystem, which is built around our hardwares to it. Yeah, thank you. This is from my side, thank you.